Hi, welcome back. So in this video, we're going to talk about matrix multiplication. So our plan is to talk first about the theoretical parts of matrix multiplication and give a general formula. Then we'll do an example, and we'll end the video with some notes about matrix multiplication of just some important things to remember. So please try to stick around till the end so you can get those extra notes that we have after the example. Alright, so thus far we have discussed how to find A times X, where X is a vector. So we've done matrix times vector multiplication. But now we're going to start doing our matrix times matrix multiplication. So the way we define it is going to look a little complicated, but it's based off of what we do for A times X. So we say that the matrix multiplication AB is defined as the following. So if we have A, which is the matrix made from the columns V1 through Vn, and B is the matrix with columns B1 through BP, then we define our product AB to be A with the matrix B next to it, and then what we do is we write a new matrix where we do A times each of those column vectors of B as our new columns. So this looks like A times B1 as our first column, A times B2 as our second column, all the way to A times BP as our final column. So we're doing these individual matrix vector multiplications as each of the columns of this new matrix. Alright, so this is built on our idea of matrix vector multiplication, and let's go through and unpack some of the dimensions here. So in order for this to work, we're going to need to do the A times B matrix vector multiplication. So this means our vectors B1 through BP must be vectors that have n components. That's because our matrix A had n columns, and we need one element of B for each column. It's basically that every column represents a variable in our system, and so the vector we multiply by is going to need as many elements as there are variables. So if we look at our matrix A, this is an m by n matrix because those vectors, let's say they're part of Rm. Then the matrix B is an n by p matrix. That's what we're saying it has to be. So those vectors, each of the B1 through BP, they must have n components in them in order to make the multiplication work. Then if we look at our multiplication that we're doing, A times B, each of these columns is an m by 1 column. Then we have all of these columns, and we have a total of p columns, since that's how many vectors we have. So the resulting matrix A times B is going to be an m by p matrix. So something to note is in the A and the B, we see these inside dimensions in the way they are written match. So m by n, and then n by p. So the n's match on the inside. Then the resulting matrix has the outside dimensions, m by p. So we need those inside dimensions to match in order to make the multiplication work. Alright, so this is really theoretical and is sort of just the way that we define this formally, but I think it helps to see an example so you can see how the multiplication works. So let's find the matrix product A times B. If A is a 3 by 2 matrix, 5, 3, 2, -1, 0, 1, and B is a 2 by 4 matrix, 1, 10, 7, -5, -1, 0, 6, 3. So when we do the multiplication, we do A times B. I'm going to write the matrices next to each other here, and then I like to make sure that the dimensions are going to work. So as I said, A is 3 by 2, and B is 2 by 4. So we see here that the inside dimensions, the ones that are listed closest together, match. So we have a 2 and a 2. And so the resulting matrix is going to be a 3 by 4 matrix. Knowing this ahead of time can make sure that you have some confidence as you're going through the process that you're doing it correctly. So as we get more practice with this, we don't need to write as many steps, but I'm going to write quite a few here just to give us a sense of what's going on. So each of our columns is going to be a matrix vector multiplication. So we're going to have our matrix A in each of our 4 columns, and then we'll multiply it by a corresponding vector. So in the first column, we multiply by the first vector. In the second column, we multiply by the second vector. Third column is third vector, and fourth column is fourth vector. Then I'm just doing basically 4 little mini problems where I do matrix vector multiplication within this larger problem. So I'm going to go column by column. So for my first column in this matrix vector multiplication, I'm doing 5 times 1 plus 3 times -1, then 2 times 1 plus -1 times -1, and then 0 times 1 plus 1 times -1. Okay, so that's my first column of my final answer. Then let's do the next column. I repeat a very similar process, so I do 5 times 10 plus 3 times 0, 2 times 10 plus -1 times 0, and 0 times 10 plus 1 times 0. Okay, that's the second column of my final answer. Then I repeat this for the third column, 5 times 7 plus 3 times 6, 2 times 7 plus -1 times 6, 0 times 7 plus 1 times 6, and that's my third column. Okay, we're almost there. Let's do the fourth column. So 5 times -5 plus 3 times 3, 2 times -5 plus -1 times 3, and 0 times -5 plus 1 times 3. So here you should be able to see that in each of these columns we're multiplying by the vectors, and we have that 5, 3, 2, -1, 0, 1 every single column. The thing that's just changing is the vector that we're multiplying by. So now we're just left to simplify. So I'm going to write out here, I've done the initial multiplication. I don't want to talk through each of that because at this point I think we can do that multiplication. And then I'm just left to simplify. So in my first column, I'm getting 2, 3, -1. Second column is 50, 20, 0. Third column is 53, 8, 6. And the fourth column is -16, -13, 3. And that is my final answer for the matrix multiplication. We can also confirm this is a 3 by 4 matrix as we expected. All right, so oftentimes this matrix multiplication just takes seeing some examples and really practicing it quite a few times. There's lots of calculations that make up this, and it can be kind of hard to remember the process or make sense of it, especially when you're learning it for the first time. So just be patient and keep working at it. I want to close the video with some notes about matrix multiplication. So firstly, you might have noticed that we don't typically use a symbol for matrix multiplication. Instead, we just write the letters next to each other. So I write like A, B, just right next to each other. We might still read it as A times B, or the matrix AB, but we don't put a symbol there. So if you really want to, you can totally use a dot or a star or even an X to represent the multiplication, but just know that when you do that, it isn't really the standard convention. That's fine if you choose to do it, but just know that most of the time we're not doing that because those symbols are reserved for other things. However, I know for me, when I was learning this, it sometimes really helped me just to put the symbol in, and so hey, I think it's fine if that's what you decide to do. Then, as we mentioned, the operation of matrix multiplication is defined only when the inner dimensions match. And I say inner to refer to the ones that are written close together on the inside when we write them out. So if we have A times B equals AB, and the matrix A is M by N, and the matrix B is N by P, those n's on the inside need to be the same in order to even do the multiplication in the first place. Then the resulting vector will be M by P. Then lastly, this multiplication doesn't necessarily work like other types of multiplication. So not all of our usual multiplication properties will work here when we're doing matrix multiplication. So some of them do work. So matrix multiplication is associative and distributive. So for associative, if we do AB, then times C, this is the same as doing A times BC. So we can do A times B first, then multiply by C, or we can do B times C first and then multiply by A. So this means that it's associative. Matrix multiplication works in this way. Matrix multiplication is also distributive. So if you have A plus B and you want to multiply it by C, you can do A times C plus B times C. so it's distributive. We can distribute that C to both A and B. However, matrix multiplication is notably not commutative. So commutative means that we can swap the order of multiplication. So we cannot assume that A times B is equal to B times A. These things are not equal except in special circumstances. This should especially stand out because if you think about having the dimensions need to match, there's going to be cases where if you swapped the order, we can't even compute the matrix multiplication. But even if you can do the matrix multiplication, just know that you really can't assume that you can get the same thing if you multiply either direction. So this is the commutative property, and it does not work for matrix multiplication except in special circumstances where we have certain properties of our matrices. Alright, so that is an introduction to matrix multiplication. Thanks so much for watching, and I will talk to you in the next one.